Good evening. I am Aditya Venkatraman. Today, I'll be presenting my data story on household energy consumption and exploring one key question. Can small behavioral changes at home meaningfully reduce overall energy demand? While climate change is often discussed at a global scale, this project focuses on the household level. Using real consumption data, I analyzed seasonal energy patterns, identified major energy contributors, and simulated the impact of a modest 10% reduction in usage. So, the first part is understanding the monthly household patterns. So, let's begin with the first chart. So, this line graph shows the average household power usage per month measured in kilowatt hours. It is important to clarify what this means. Kilowatt represent instantaneous power demand, not the total monthly energy consumption. So each point on this graph shows the average monthly power being drawn at any minute throughout the month. So in simple terms, the January month shows 1.5 kilowatt. It means that on average, the household was drawing 1.5 kilowatts of electricity at any moment during that month. For the graph, we can from the graph we can clearly observe higher usage in months like January and December. So we can see in December it has been the maximum of 1.637, and also a sharp rise that is happening during from the autumn months. So this pattern strongly suggests that seasonal heating demand is a major driver of energy consumption. I will show why it's seasonal heating demand from the next graph that I'm going to show. That is which appliances consume the most. So from this, we look at appliance category breakdown. This bar chart shows the average monthly energy usage per minute measured in watt hours for different appliance groups. For example, for heating and heater, we can see it's 5.934. For laundry, it's somewhere 1.475, and for kitchen, it's 1.177. So from this, we can clearly see that for heating and water, it dominates the consumption. This aligns with the seasonal pattern observed earlier in the first graph. When heating demand increases, overall power usage rises significantly. Laundry and kitchen appliances contribute, but their impact is considerably smaller in comparison to heating and water. This reinforces the idea that heating behavior plays the largest role in household energy demand, which moves us to the final part where I'll be simulating a 10% reduction. So in this, it's basically the blue line is the first visualization that I showed, and the orange line shows what will be the average power consumption over the month of 1 year if we just reduce our power usage by just 10%. So again, the values are measured in kilowatts, representing the average power demand. What is important is that the numerical decrease, but also the consistency of impact across all months. So, for example, during the earlier peak, it was 1.637, but now after the 10% reduction, it is 1.473. So, if we compare it with the blue line, it's probably December month is probably consuming the same power as mid October or early November. So this demonstrates that even modest behavioral adjustments such as lowering thermostat settings, improving insulation, or using heating more efficiently and effectively can produce measurable decreases in household power demand. While this does not directly calculate the total kilowatt hours saved, reducing average power demand over time would naturally translate into lower total energy consumption. Why this matters is that the analysis is not just for seasonal variation. It is that it is small, but it's consistent behavioral changes which can meaningfully reduce household energy intensity. When scaled across hundreds and thousands of households, even a 10% reduction could significantly lower electricity demand and associated emissions. So this is like a dashboard which integrates all the three graphs. The first graph, the average monthly energy consumption over a period of 12 months. The second graph which shows the appliances breakdown, and the third graph which is a 10% simulation of how the consumption will vary. So to conclude, household energy demand follows a clear seasonal pattern. Heating is the primary contributor to high consumption. At a modest of 10% reduction in average house power demand shows consistent impact across the year. Small changes when multiplied across households truly can create a big impact. Thank you.